So, hello everyone again. This is lecture number 7, part 1 of semiconductor electronics, materials, devices and simple circuits. In the previous lecture, we have completed with the Zener diodes and the photodiodes. Today, we will move on with the next example of this optoelectronic devices, which is light emitting diode. After light emitting diode, we will move on to solar devices, and that will be the end of the this subtopic which we are working upon. Okay. So, let us start the discussion today. So, I am Sameer Lavankar. Let us begin our discussion. Okay, so first of all a course outline for you. So, right now we are on the 8th topic, that is special purposes PN junction diodes. Before this we have completed with the introduction part, in which we understood as in what is basically cathode ray tubes. So, we understood about cathode ray tubes there, so these are also basically semiconductor devices only. Which were very large in size. Okay. And so, basically we found out that what were cathode ray tubes and how were they different from the present integrated circuits or integrated chips which are being working upon. Okay. So, we will also understand a little bit more about ICs, and that is integrated circuits, which is the last part of this lecture series. So, that being said, in the introduction we understood the basic comparison between both of them, that is cathode ray tubes and the presently working upon integrated circuits. What was the size comparison, what is the speed comparison, how many are being available, what is the basic difference, how this complete era started, and so on. Then the next about classification of metals, conductors and semiconductors. We understood basically different phenomena such as valence band, then conduction band, and energy gap theory of solids, etc. were being understood in this, in which we understood that if the valence band and the conduction band are joining apart, or they are overlapping, then those materials will be called as your conductors. If there is a very small gap, let us say in approximately of 1 electron volts or so on, 0.7 to 1.5 we can say, then those are called as your semiconductors. And if it is very high, such that even about if the very large amount of energy is provided to the electrons in the valence band, it cannot go to the conduction band, then those are called as your nothing but insulators. Okay. So, that thing being said, we understood this complete concept in your second point, that is a classification of metals, conductors and semiconductors. Then next was about intrinsic semiconductors. Then we get to know about intrinsic, then extrinsic semiconductors. Extrinsic was basically of two types. One was your p type and another was an n type. Okay. So, in a p type semiconductor, basically we a trivalent impurity was being used for doping, and in an n type semiconductor a pentavalent impurity was being used for doping. Then we understood the p-n junction. In this p-n junction we also understood concepts such as depletion region and so on. Then in the sixth topic, that is semiconductor diodes, we understood that what is forward biasing, what is reverse biasing. So, these all concepts were being dealt there. So, we understood what is forward biasing, what is reverse biasing. Then we also understood what is the what are the VI characteristics of a forward and the reverse biasing. Then in the seventh topic about application of junction diode as a rectifier, we basically understood three different types, obviously three different subtopics in this. The first was your half wave rectifier. The second was your full wave rectifier, and the third was your this filters. Okay, so these were all the concepts which we studied in this. Then moving on about the special purpose PN junction diodes, currently we are on this topic about special purpose PN junction diode, in which we started our concept with understanding about the Zener diode. Please remember, Zener diodes works in or is being used to work in your reverse biased condition. Okay, and the second thing is based upon your photodiode. This also works in reverse biased condition or operates in reverse biased condition. Fine. So, that all things being said, let us now move on to the concept which we will study from now onwards, which is based upon your complete analogy of LEDs, that is light emitting diodes, and then we can move on to the solar cells. Okay. So, let us start with this discussion directly, that is special purpose PN junction diodes. So, we started with the Zener diode concept, correct, in which we understood this VI characteristics. The next was how a Zener diode can be used as a voltage regulator. We understood this concept. We did an example on this. Please remember that the Zener current is approximately 5 times the load current. So, if the load current is given to you in the question as 4 milliamperes, then what will you use the Zener current to be? You will use this equal to approximately 5 times. So, it is 5 times 4, which gives you 20 milliamperes in the example which is provided here. Okay. Fine. Next thing is your optoelectronic junction devices, in which we have completed the first one, that is photodiode. What is the basic use of photodiode? Photodiode is used for detecting the optical signals. Then next comes light emitting diode. In light emitting diode, what is the basic usage? It converts the electrical energy into light. The third after this, which we will be understanding, will be photovoltaic devices, which converts the optical radiation into electricity, that is basically the solar cells. One of the example of this is solar cells. Okay. So, let us start directly. So, this was the VI characteristics for your photodiode. Okay. And then we also understood this phenomena, in which we understood what is the values of fractional change in the majority carrier. So, basically what is the reason for operating the photodiode in reverse bias. So, this was a question based upon this. So, this was basically done to understand more about the photodiodes. Fine. So, now let us start today's discussion, that is based upon the light emitting diode. Okay. So, let me first of all iterate. So, this is one of the basic example, this is one of the easiest figure which we can understand. So, you do not need to understand each and everything which is written here. For now you can just see, okay, so we know what is a LED. So, basically LED is a light emitting diode. Okay. So, what are the basic uses of light emitting diode, whatever is required will be conveyed in this lecture. Okay. So, light emitting diode. So, it is heavily doped PN junction. It is heavily doped. What is the meaning of heavily doped? So, heavily doped basically means that the impurity concentration being added to the semiconductor device or into the semiconductor is very high. Okay. So, it is a heavily doped PN junction which under forward bias emits spontaneous radiation. Okay. So, this time our example of understanding the special junction PN junction diode is basically a forward bias. Okay. So, just for a revision, I am just I will keep on explaining these things again. So, please remember, Zener diode works in reverse bias, photodiode works in reverse bias, light emitting diode, that is LED, works in forward bias till now. Okay. So, it is heavily doped PN junction which under forward bias emits spontaneous radiation. the diode is encapsulated with a transparent cover, so that the emitted light can come out. So, this is basically a transparent cover which is they are conveying here. So, basically what they are saying is that it is encapsulated with a transparent cover. So, this is the cover being talked about here, so that light emitted can come out. Okay, so that the light emitted can come out. When the diode is forward biased, electrons are sent from N to P, quite evident. So, this is a basic analogy which we understood in the semiconductors, that what is happening in forward bias and what is happening in reverse bias. Okay. So, in reverse bias basically minority concentration, charge carrier concentration takes place across the depletion region, and in the forward bias basically the thing which is given here is being talked about. So, when the diode is forward biased, electrons are sent from N to P, quite evident. So, majority charge carriers on the N side is electrons only. So, they are being sent from N to P. Where they are sent? They are sent to the minority carrier portion, where they are in minority, and similarly holes are sent from P to N, where they are minority carriers. Fine. So, this thing is okay. Next is, at the junction boundary, the concentration of minority carriers increases compared to the equilibrium concentration. Quite evident, this was also we understood in the forward biasing concept only, that as we keep on working upon, we can attain a stage at which the equilibrium happens. So, at the junction boundary, the concentration of minority carrier increases, quite evident, the minority carrier will increase compared to the equilibrium concentration, that is what is the equilibrium concentration? When there is no bias. Thus, at the junction boundary, on either side of the junction, excess minority carriers are there, which recombine with majority carriers near the junction. Okay. So, what is being explained here, that what happens at junction boundary, at junction boundary. So, let us suppose this is your PN junction diode, this is the depletion region. So, at the junction boundary, so basically they are talking about these portions here. So, at the junction boundary, on either side of the junction, excess minority carriers are there, which recombine with majority carriers near the junction. So, basically excess minority carriers are present here, which recombine with the majority carriers. So, here recombination is happening at these locations, recombination is happening. Fine. Next thing is, on recombination the energy is released in the form of photons. Okay. So, on recombination the energy is released in the form of photons. What is photons? Photons are basically particles which are having an energy which is equal to h nu. So, photons with energy equal to or slightly less than the band gap are emitted, quite evident. So, basically this is the same concept which you understood in dual nature of radiation and matter also. So, which of those which are having energy which is less than your h nu or h nu will be emitted. Okay. So, basically they cannot be used because the energy is very less for them to occur into the next stage. Okay. So, photons with energy equal to or slightly less than the band gap, we know what is band gap here, Ag is the band gap, are emitted. When the forward current of the diode is small, the intensity of light emitted is small, quite evident. So, if you will give less amount of energy, then the amount of photons will be produced will be less. If the amount of photons which are produced is less, then the amount of intensity will also be less. Okay. As the forward current increases, intensity of light increases and reaches a maximum. So, it cannot be that the intensity keeps on going till infinity, it will go and go and it will go till the intensity is at its max place. So, intensity can only reach up to maximum. Fine. Further increase in the forward current results in decrease of the light intensity. Okay. So, further increase in the forward current results in decrease of light intensity. So, basically the intensity keeps on increasing first and then it keeps and then it decreases. Okay. LEDs are biased such that the light emitting efficiency is maximum. Okay. So, they are biased basically. What is the meaning of biased here? Please remember, biased as in any external applied voltage is called as bias. Okay. So, LEDs are biased as in they are being applied to an external voltage. So, LEDs are biased such that the light emitting efficiency is maximum. What does it mean? That is, we apply such amount of current into it, so that the intensity which can be obtained is maximum, or we can say that the intensity which is obtained is optimum. Okay. So, the external applied voltage is being applied in such a sense that the emitting frequency, that is emitting efficiency, is the maximum. Okay. Fine. Next thing is, the VI characteristics of LED is similar to that of a silicon junction diode. Okay. but the threshold voltages are much higher and the slightly different for each color. Okay. So, threshold voltages are different for each of those colors. Fine. Moving on. Reverse breakdown voltage. We understood the concept of reverse breakdown voltage in the semiconductor diodes when we were understanding the reverse biasing. So, basically what happens is, let us suppose this is V, this is I, this is V again and this is I, then very small current appears and then there is a jump at this place. So, this jump place is nothing but called as your breakdown voltage. Okay. So, the reverse breakdown voltages of LEDs are very low and they are typically around 5 volts. Okay. So, the reverse breakdown voltages of LEDs are very low, which is typically around 5 volts. So, basically, and that is the only reason, that is the only you can understand from this. Let us suppose by mistake, okay. So, all the Diwali lights which you generally use in your households or let us say in your schools etc., those generally are made up of LED lights only. Okay. If by mistake we reverse the polarity and drop the sign, then if by overheating once the LED fail, then it cannot be started again. Okay. So, that is the main reason why the LEDs cannot be started again, because generally the reverse breakdown voltage of these LEDs are very low. Okay. Fine. So, take care care should be taken that the high reverse voltages do not appear across them. So, if high reverse voltages appear across them, then what would happen? There would be decrease in the there would be breakages and hence damage of the LEDs would happen. Next is LEDs that can emit red, yellow, orange, green and blue light are commercially available. So, these are different ways in which these are different colors which the light emitting diodes can basically emit. The semiconductor used for fabrication of visible LEDs must have at least a band gap of 1.8 electron volts. Okay. So, band gap as in the value of Eg is given to you, that is Eg should be approximately equal to, or basically the value of Eg should be greater than or equal to 1.8 electron volts. Okay. So, the semiconductor used for fabrication of visible LEDs, what does it mean by visible LEDs? The making up of those LEDs which have light in the visible frequency of the let us suppose human eye, okay, must have at least a band gap of 1.8 electron volts, that is spectral range of visible light is about 0.4 micrometers to 0.7 micrometers. Okay. So, they are just telling you the spectral range. Okay. These are basically the wavelengths of your red and violet color. Fine. So, that thing being said, that is about 3 electron volts to 1.8 electron volts. So, that is the range we are generally observing, or that should be observed. So, that those semiconductors should be used which have at least such a band gap. Okay. Next thing is the compound semiconductors gallium arsenide phosphide. So, this is the complete name of one of the semiconductor, you can understand. So, Ga is gallium, arsenide is basically given like this and phosphorus is like this, is used for making LEDs of different colors. For example is given to you in the picture. So, GaAs, if you remember, if you see it correctly, if X is being used for phosphorus, then 1 minus X will be used for arsenic. So, X value will always be lying between 0 and 1 only. So, if X is 0.4, then arsenic will be 1 minus X, that is 0.6, which is used for red LED. Okay. Then gallium arsenide, which is having an energy gap of approximately 1.4 electron volt, is used for making infrared LED. Quite evident, infrared LED is not visible to us. These LEDs find extensive use. Where are these used? What are the applications? So, one is in remote controls. So, basically if you see correctly your remote, so there is a light being emitted whenever you press a button, correct. So, that is how LEDs are being used there. Then burglar alarm systems. So, if you have remember correctly, there is a siren which is working upon and there is a rotatory thing which keeps on working, so that you can see a red light from far off places. So, there that is where LEDs light are being used. Optical communication also LEDs are used, okay, because these are cheap also and easy to make also. So, extensive research is being done for developing white LEDs which can replace the incandescent lamp. So, this is just a fact explaining here that extensive research is being done for developing white LEDs which can replace incandescent lamp. So, that efficiency is increased and the amount of money required is decreased to a much extent, if that is the case here. Fine. So, let me stop this lecture here only. In the next lecture we will be starting with the new special purpose PN junction diodes, that is solar cell. Okay. So, that is it for this part of the lecture. So, thank you so much.